things that go there in a spot.
He's got his league yesterday. What is this sig dot
So,
on the right side?
CSC, is that the one you're looking at?
And then you do like, what is it?
They're the if you look at them with the one they're next to, they're reciprocals. So sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, see, it's just a reciprocal. Cosine and secant are reciprocals,
Okay,
and then tangent and cotangent are reciprocals.
right, something like that.
It's however you're gonna use your notes, this is all you. And I told you in your, Google Classroom yesterday, I put in there that unit circle, and I've got it on paper too. This is gonna be your lifesaver, the unit circle is gonna be your lifesaver for this trig unit. If you actually take the trig class, we're just gonna scratch the surface, this is algebra 2, but we have some trig stuff we have to cover because it's on the ACT. But, if you actually take trig next year, we're gonna do this in a couple of weeks. Y'all are gonna have a whole semester on it, so y'all are gonna get much more in depth. So y'all start off in trig class, Miss Stewart next year, she gives you this unit circle blank, and y'all figure out where all that stuff came from.
I won't figure it out.
Okay.
So if I hang on to this for a year,
Well, yeah,
Yeah.
but I'm just telling you, that's, we're skimming the surface, the class actually goes in depth.
Is that SEC?
SEC.
Put it in, put it in.
I was thinking you said.
That's in it though, what am I saying?
We will use this unit circle to depth. So you've got it electronically and paperly, paperly. This was the first paper I passed out all year long because we weren't supposed to pass
Yeah.
out papers.
It.
I think I'll take a picture of it and save it.
Here you go, Zach's gonna keep it for.
That's what he always does.
Gotta be
Yeah.
thinking
He's gonna wait
in a
for that.
long game.
A year ago today,
Yeah.
pop up.
A year ago today, I was probably still counting those ceiling tiles.
Yeah.
A year ago today, we were at home
Yep.
Yeah.
wondering what was gonna happen with this pandemic.
Oh, that's true.
We were still in the phase of, we might go back next week. We might go back next week. And
Yep.
finally.
I remember being so mad too, because they shut down, we were supposed to go skiing that week, and they shut everything down, right? So,
Alright, so everybody got that page ready for the next one? The next page, it just gives you some of the angles that are actually on your unit circle, but it's pretty handy to have, cause it saves you a lot of work.
Isn't the hypotenuse the long side of the triangle?
Yeah,
No.
we'll talk about all that.
Hypotenuse and
Okay, so what all that is, I know it looks overwhelming to you, you got, first off, a 30, 60, 90 triangle on the left. We have labeled those 30, 60, 90, even though they look the same. Then you got a 45, 45, 90 triangle on the right. This is how the actual unit circle is derived, by using Pythagorean Theorem and angle shortcuts. They find all that stuff. What you're gonna wanna know on a test or an assignment where this is gonna come in handy, instead of having to figure out and look around and actually compute mathematically, either on your unit circle, which I'll teach you how to use, or here, if I ask you for the tangent of a 60-degree angle, you already know it. Okay? It's the square root of 3. So get this down. This is a time saver, Christian.
oh, is it because it's the opposite?
Mhm.
Okay, yeah, I remember doing this.
Yeah, y'all did a little bit of this in geometry.
What's the thing, that's the circle?
paper actually has lines to do that.
One time we were sitting in church, and I was sitting by my sister, and I don't remember what it was, but there was some verse that we were talking about that I wanted to underline in my Bible, and I was struggling. My underlining was like marking out the words, actually. She's like, what's wrong with you? I was like, I don't know. She said, just do it real fast, and that didn't get any better.
Let's see, how big is that table?
That's it.
6 lines.
Oh, I thought you meant like, is there more underneath there?
6 lines up and down. Do we have to have the circle crossed out thing along with it?
Well, it goes there, yeah.
There always gonna be a specific thing, like, so not the hypotenuse, but the longer angle of the two other ones is
I don't understand.
it's like on the left triangle,
Mhm.
so it's like the COS 45 is how they're gonna do.
Well, there's not a 45 on the left triangle.
COS 30 would always be a certain number, or that certain side.
Yeah, I mean, cosine of 30 is going to be square root of 3 over 2 every single time, no matter how big the triangle gets, every time.
Okay.
I don't know. I don't know. Maybe it'll make more sense to me what you mean later. No, I don't really think this is what Christian was talking about, but a little bit on these same lines. There's gonna be different angles, like 30, 60, 90, and 45, 45, 90 are just the most common. So we're gonna get to a point where we might need the cosine of a 58-degree angle. Okay, so these shortcuts aren't gonna help us then, but these are the most common, so we've got our shortcuts.
These are all the opposite of each other.
So now what?
So these are all the opposite of each other. Like sin cos, and then tan and cot,
Noticing some
CST,
relationships.
SST.
Alright, so we're finishing this up, so you're still writing and you're okay. First off, those are pronounced sine, cosine, tangent, those are abbreviations. I don't really understand why sine, S-I-N-E, needs an abbreviation when you just chop one letter off. But, the first time we start this every year, someone will say sin, well, it's sine. So sine, cosine, tangent. And then those other three, like I was talking with Christian about, are the reciprocals, cosecant, secant, and cotangent. Now, there are little acronyms or whatever different ways of memorizing these. I'll talk to you about a few of those first. First thing, the way I remembered it back in the dark ages when I was in school, you just remember that sine, cosine, tangent, it's always in that order. And then here's what I said. Let me write it all down and then I'll read it with my little saying.
So,
SOHCAHTOA is one way, I'll get to that, that's not what I was gonna do first, but I will. Okay, so my Algebra 2 teacher said, and this is the way I've always remembered it, this is opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent, that's what, so I said, she said, Oscar has a heap of apples. And as doofusy as that is, I've always remembered that. A few years ago, a student using those same letters said, and this one's funny, oh heck, another hour of algebra. So that one was pretty funny. And then what y'all said, y'all already knew, if we put all this together, sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent, SOHCAHTOA, and people made up stories about an Indian
like
princess or something like that named SOHCAHTOA. Okay, I know there is one about old hippies doing drugs, but we are not old hippies and we don't do drugs, so we're not going to use that one. Okay, Zach's like, dang. All right. Now I don't. There's not any one for the reciprocal ones like cosecant, secant, or cotangent. I don't worry about that because if I can get these three right, cosecant just takes the reciprocal, secant just takes the reciprocal, and cotangent just takes the reciprocal. Okay. All right. So let's figure out what a hypotenuse and an adjacent and an opposite and all that is. Let's do some work. Draw us a triangle. Well, it's not really what I wanted.
perfect triangle.
Yeah, but I wanted,
That's a 45 degree,
yeah,
no matter
I'm just
what.
gonna draw one, cause that's
It's
not
a
gonna
right
work.
triangle function.
Let's just draw one.
Talking about the other two angles, of course, is the right triangle.
Okay,
Both good.
okay,
Thought
so
you
here
were
we
gonna
got a
guess
right
that.
triangle. So, first off, you will always use your theta or variable will always be in an acute angle. You won't ever have your theta as the right angle. Okay, it'll always be in the acute angle. So I could have put it in either one of these, but I just chose this one to go over what everything means. Yes.
So if it's not on right triangle, it won't be an obtuse.
We're not that far yet. Slow down, Scooter. Alright, so from theta, 12 doesn't touch my angle at all. The side length that's 12 is not touching that angle at all, so it is opposite. So that one would be our opposite. 5 is touching it. It's like its next door neighbor. So 5 is touching it. It is the adjacent. The hypotenuse is always the longest leg, and if you can't tell by looking, it's across from the 90-degree angle. Okay?
Let's say by.
Where? No, HYP,
Oh,
hypotenuse. Okay, so we can label those. We can do that pretty good. So the question says to find the 6 trigonometric functions. Okay, so that means sine, cosine, tangent, cosecant, secant, cotangent. But we can't do that yet because we don't know all the sides of that triangle. Do we know how to find that hypotenuse?
No.
Yes, you do.
Yes, we do. We add
A
5
squared
squared
plus
plus
b
12
Very
squared.
good. We need to use the Pythagorean Theorem to solve for the C there, to solve for the hypotenuse. So 5 squared plus 12 squared equals C squared.
So, 169. No, yeah, 169.
I was just listening to you. I hope you're right. Square root of 169 is? Check me, make sure, but I'm pretty sure it's 13.
It sounds
25.
13. So we now know our hypotenuse is 13. Now, if we were doing that math just then, and we would have gotten an answer like 11, we would need to know we screwed up. Because it's got to be longer. It's got to be your longest leg. So it had to be longer than 12. 13 is a little longer than 12. Okay, I'm going to erase that. Pythagorean Theorem works, so we've got room to do our trig functions. So, let me just get them all ready. Sine of theta, cosine of theta, and tangent. I'm gonna just start us with that, okay? Sine is opposite, so looking from theta, what's opposite? 12 over hypotenuse,
13.
13. There's the sine of angle theta, that's all you gotta do. Okay, cosine is adjacent, so what's adjacent to theta?
5.
Over hypotenuse.
Wait, aren't they both, like, isn't the hypotenuse also adjacent?
But the hypotenuse is only the hypotenuse. Yes, it is also adjacent, but it's only, you can only use it as the hypotenuse. So what's our hypotenuse?
Hypotenuse.
13.
13. Tangent is opposite. What's opposite of theta?
12.
Over adjacent.
5.
That's it. You know your sine, cosine, tangent. Now the problem asks for all 6, so now we need to know the reciprocals. So we need secant. Oh, hold on, I got that in the wrong order. Cosecant comes with sine, right?
I don't know.
Well, look at your notes. We already wrote it down. Cosecant of theta, right? Secant of theta and cotangent of theta. So all I have to do now is take the reciprocals. So 13 over 12 is the cosecant. 13 over 5 is the
Very easy.
cosecant. And 5 over 12 is the cosecant. So actual math that we did was not new. It was the Pythagorean Theorem, which you did that to death in geometry. So we did that to figure out our hypotenuse, and then we just either had it memorized, oh heck, another hour of algebra, and plugged them in, or we looked at our notes and plugged them in. Let's try something else. Got what we need on that page? Christian, you gonna be able to help? Yeah.
He's flabbergasted right now.
He said, yeah. Alright, fixing to shift your gears.
Have you used that word?
Oh, good one. Flabbergasted. Okay, so I'm telling you that there's some triangle floating around out there that the sine of its angle theta is 4/7. And I want us to find what the tangent of that same angle would be. Okay, so I got some triangle, so I'm just gonna draw me a little triangle here. This is your thought process. So there's my 90-degree angle. So I'm gonna put theta down here this time. Sine is opposite over hypotenuse, true?
No.
So the opposite right here would be 4. Hypotenuse would be 7. There's my adjacent. Tangent needs opposite, which I already have, which is 4, over adjacent, which I don't have. So what are we gonna do to figure out adjacent?
7 squared minus 4 squared.
Pythagorean Theorem, but it's not C we're solving for this time is what Christian meant, so 4 squared plus, I don't know squared, put whatever variable you want there, it would have made more sense, I guess if I put an A, equals 7 squared, because 7's your hypotenuse. So 16 plus, I don't know, squared is equal to 49. Subtractamundo, you're 16.
23.
X squared is equal to 33.
Oh!
I was just saying.
Undo your squared by square rooting, so that side would have to be the square root of 33, because that's not a perfect square, there's not one that will go in there. Now's where we got a dilemma, because when I go put that over here, 4 over square root of 33, we remember back from first semester, we can't leave a radical on bottom.
So
So,
flip it and make it negative.
well, no, whoa, simmer down. Let me erase my Pythagorean Theorem, and this is called Rationalizing the Denominator, what we're fixing to do. Come on, get out of here, Pythagorean Theorem. Alright, so we've got 4 over the square root of 33, and we need to cancel out a square root of 33 on the bottom. So anytime it's a square root, you can multiply it by itself. Y'all remember that? For example, up here on the top on a side note, square root of 2 times the square root of 2 is the square root of 4, which is 2. So if you multiply it by itself, you just lose the radical, right? So I could do this bottom times the square root of 33, which just like up here with the 2 left you with 2. So that's going to leave you with the 33 on bottom. But whatever you do on bottom,
You have to do
you have to do on top. So what's 4 times the square root of 33?
No idea.
But it's just 4 times the square root of 33. That's it. That's not my answer. I shouldn't have circled that big. My final answer is, well, that is too my answer. Yes, it is. That's it. So we did the Pythagorean Theorem there, which y'all are pros at. The hardest math that we did with that was that rationalizing the denominator, getting rid of the radical on bottom.
We've always done it with Pythagorean theorem. If we have the hypotenuse and we're missing one of the legs, we just do subtraction.
Yeah. And I did that the long way. I went ahead and wrote it out in Pythagorean Theorem, but then I had to subtract from both sides. So y'all just jumped a step faster than me, which is fabuloso. Okay, let's see if we can use our shortcut sheet now. So you got your 30, 60, 90, 45, 45 shortcut sheet. That's my 30-degree angle there. This is 8, and this is X.
What are we trying to find?
Well, I haven't told you yet, just simmer down. So what we're gonna look at here is to find the value of X. Okay, so from 30 degrees, what do we know about 8?
It's third of the circle thing.
What do we know about 8? Is that opposite, adjacent, or hypotenuse?
Hypotenuse.
It's hypotenuse because it's opposite the 90-degree angle. What do we know about X? Is that opposite or adjacent?
Adjacent.
Adjacent. So if I'm trying to find out X, I'm trying to find out adjacent. So I'm dealing with adjacent and hypotenuse. Which of the 3, sine, cosine, or tangent, has that in it?
Cosine.
Cosine. So the cosine of 30 degrees is equal to adjacent over hypotenuse. Right? Now, you've got a cheat sheet that tells you what the cosine of 30 degrees is.
Square root of
Everybody see where Christian's getting at? I don't think it's the square root of 3.
Is square root of 3 over 2.
Okay? Square root of 3 over 2.
That's what the adjacent is. Square root of 3.
Okay. So thank you. Square root of, I'm not there yet. Square root of 3 over 2 is equal to X over 8. Now what we've set up there
Cross multiplication.
is an easy proportion, and you just cross multiply to solve. So that gets me 8 square roots of 3 equals 2x. I'm trying to solve for x, so what would I do to get the x all by itself?
Divide by 2.
Divide by 2.
I would not have done
Well, you didn't get the right answer either, because 8 divided by 2 is 4, so 4 square roots of 3 is what our adjacent is.
that. I would have just multiplied the left side by 4 and then said by 5. I'm just that's my question.
What you get for going ahead.
Huh?
What you get for going ahead.
Okay.
Now, go ahead, and on your unit circle, we're not gonna use the unit circle as much today, but go ahead and grab that real quick, because I wanna show you some stuff. And go find the 30-degree line on it. Put your finger on 30 degrees.
Pi over 6.
Yeah, it's by the pi over 6. Everybody there? We're on the unit circle.
Oh shit.
Now, you 30 degrees, and then you see pi over 6, and then you see an ordered pair, right? Everybody got your finger on that ordered pair? Square root of 3 over 2, comma 1 over 2. That ordered pair is cosine, comma sine. So if you needed the cosine of a 30-degree angle, just a second ago we looked on our cheat sheet, or you could also look right here, cosine of a 30-degree angle square root of 3 over 2. Okay, that ordered pair, and it tells you that up there at the top. That ordered pair is cosine comma sine. Okay, this is going to come in super duper duper handy. So let's look real quick and let's see if we can find the sine of 150 degrees just by looking at this unit circle. Sine of 150 degrees.
1 over 2.
1 over 2. Everybody see where Tyler got that? You see, Christian?
Sure.
Well, that's not very.
Oh, yes.
Okay.
I was thinking Sine went first, but no.
Alright, let's see what else we got.
Does it ever show tangent on these?
Well, it tells you tangent is
Tangent
sine
both
over
of them.
cosine. So you just like for this one, sine over cosine, so that would be 1. Same thing over itself. Alright, so let me find a good one to end us on. Tomorrow we are gonna practice on this. I've got an assignment where this is all we're gonna do is practice, but let's look at a good one to wrap it all up. How about, let's do that one. I can draw that, looks like a 45, 45. What's already like? Okay, we got that. We got theta, we got 11. Okay, so directions here say to evaluate the 6 trigonometric functions. So first thing I do, and this is just my personal preference, you can start several different ways, but first thing I do is label what I got. So they gave us theta. You can't put theta wherever you want. They gave it to us. Okay, so based on that, what is 8? Opposite, adjacent, or hypotenuse? Opposite, very good. What is 11? Hypotenuse. We need to find adjacent. How are we going to find adjacent?
Pythagorean theorem.
Pythagorean theorem. So y'all figure that out for me real quick. I'll wait. Leave it in radical form if it's not a whole number. Everybody got it yet?
This is square root of
57, is that under the radical? So the square root of 57, it's not a perfect square. I don't believe there's one that'll go evenly into it, is there? So square root of 57 is our adjacent, and all y'all did on that basically was 121 minus 64, right? And then square rooted it. Okay, so let's get ready for our first 3. Sine is opposite over hypotenuse. That's easy work there. Cosine is adjacent over hypotenuse. Is that okay to leave that like that?
Yes.
Yes, as long as the radical's not on bottom. If it's on top, it's okay. Tangent is opposite over adjacent. So now we got work to do. We can't leave that radical on bottom.
8 square root of 57 over 50.
Very good. Multiply top and bottom by square root of 57, and that gets you just exactly what Christian said. I don't want to erase my beginning answer because that might come in handy in a minute, but for my final answer on tangent, multiply top and bottom by square root of 57, and that's what you would get. Okay?
And do we have to do it?
Now we gotta do the other 3. So we scroll back up here and get cosecant. Cosecant goes first. I messed that up a minute ago for you.
What's
So
that last one?
cosecant, secant, and cotangent. Yep. Okay, so cosecant's the reciprocal of sine, so you just flip that to 11 over 8. Easy work there. Secant's the reciprocal of cosine. When you
Okay,
flip
yeah.
that, that's going to make a radical on bottom. So we got to fix that. So it's looking at, I'll go down here in the bottom corner for us. It's looking at 11 over the square root of 57, which means if you multiply the top and bottom by the square root of 57, you would have 11 square roots of 57 over 57. And Christian picked up on that pretty fast a second ago, so I just want to make sure everybody picks up on that. It just puts this up on the top and just takes away the radical. Now, when Christian did the tangent for me a minute ago, I didn't want to erase this one because this helps me get the cotangent. It's a lot easier to flip this than it is to flip that one down there. So we flip that, the radical's on top, it's okay, right? So the cotangent will be the square root of 57 over 8. And those are your 6 answers, and that's it. Now here's what happens every single year. Never misses a beat. We will do this, and we will write, those answers are not pretty. 11 square root of 57 over 57, that's not a pretty number. Everybody likes stuff like 4, 5, and 6. So we'll do this, and we'll write these ugly answers, and I'll get the assignment tomorrow, and somebody will start putting decimals. We're putting exact answers. If you do 11 square root of 57 over 57 and put a decimal, that's been rounded several times, and it's not exact. So you gotta leave them in radical form unless there's a specific question that tells you to round or gives you decimal choices. And we'll get to those later. Okay? Was there any more in this than there was when y'all did it in geometry? Shouldn't have been yet. You don't remember? Should have still been pretty close to geometry. We will do.
We never did the cosecant, secant,
okay, so the
and
reciprocals. Okay. Alright, everybody good? Don't lose that unit circle. You've got it in your Chromebook and on paper.